Good morning and welcome to our live coverage of the Twilight mission. Falcon 9 is currently scheduled to lift off at 5:44 a.m. Pacific Time from Space Launch Complex 4 East at Vandenberg Space Force Base, which is just north from us here in Hawthorne, California. My name is Tyler Lionquist, and I'm a Starlink business analyst here at SpaceX. Twilight is a dedicated small-sat rideshare mission. All of today's payloads are traveling to a specific type of sun-synchronous orbit known as a dusk-dawn crossing time orbit, which means the spacecraft will be flying roughly along the boundary between day and night, or twilight, where it's always breaking dawn. Sun-synchronous means the solar time at the spacecraft remains consistent, which provides advantages like consistent lighting for Earth imaging or for observing the sun. There are 47 payloads on this flight, including CubeSats, microsats, and hosted payloads. To date, SpaceX has launched more than 1,500 payloads to orbit for over 130 customers across our entire rideshare program. Right now, the weather is currently green on the Central Coast, and the range is ready to support. If needed, there is a backup launch opportunity tomorrow during a window that opens at 5:19 a.m. Pacific Time. One of the payloads on board today is Pandora, NASA's latest exoplanet explorer designed to look into the atmospheres of previously discovered planets orbiting distant stars. There are also 2 other NASA-related payloads on board today, manifested through NASA's CubeSat launch initiative and ExoLaunch. The Star Planet Activity Research CubeSat, or SPARCS, supported by Maverick Space Systems, is a telescope about the size and shape of a shoebox that will use thermal infrared cameras to study coronal mass ejections on small stars. And Black Cat, or Black Hole Coated Aperture Telescope CubeSat, is an X-ray space telescope that is optimized for the detection of X-ray emission from rare and bright gamma-ray bursts and X-ray flares from active galaxies with supermassive black holes. Pandora is a small satellite that will study at least 20 known planets using transits, events where planets passing in front of their stars cause tiny dips in the star's brightness. These observations will lay the groundwork for future investigations of potentially habitable worlds. So while the countdown continues, let's learn a bit more about Pandora. And there we take another step in understanding distant worlds. At SpaceX, helping to keep Earth orbit safe for everyone is a top priority, and we're committed to leading the industry in space safety, especially during rideshare missions like today's, where dozens of payloads will be deployed in a short period. Ahead of every launch, we perform a COLA, or collision avoidance screening, to ensure the safety of the rocket and payloads during launch and deployment. But pre-launch screenings are only valid for a few hours after orbital insertion, so we're working to bridge what we call the launch COLA gap, or the period of time after that pre-launch COLA screening ends, but before ground-based sensors can reliably track the satellite. We encourage satellite operators and other launch providers to join us in our effort to keep space safe and sustainable, sharing ephemeris or orbital data as soon as possible once in orbit, and keeping other satellite operators updated with high-accuracy ephemeris throughout the satellite's lifetime. As you can see in the animation, this data helps operators to predict and deconflict potential collision events. Think of it like directing air traffic here on Earth. At any point, there are tens of thousands of planes traveling around the globe. Those aircraft are broadcasting their location and flight plan to keep airspace safe. And the same needs to be true in space. When satellite operators continuously share their satellite's ephemeris data, it allows other satellite operators to detect upcoming close approaches sooner and more accurately, and perform collision avoidance maneuvers if necessary. With everyone's support, we can bridge that launch COLA gap and mitigate any risk to orbiting spacecraft,
Engine chill.
ensuring a safe environment for humanity to explore Earth orbit and beyond. For more information or to register your payload with SpaceX's conjunction screening service, visit starlink.com/satellite-operators. The Falcon 9 rocket supporting today's mission is a two-stage rocket designed for the reliable and safe transportation of satellites, cargo, and people. Starting from the very top of the rocket, we have the payload fairing. The fairing is a protective shell that houses all the payloads, shielding them from aerodynamic heating until the vehicle is outside of Earth's atmosphere. The shape of the fairing
Stage 1 RP1 load is complete.
Contributes to Falcon 9's overall efficiency, helping to reduce drag during flight. And within that fairing is today's payload. Here's a photo from midway through the encapsulation operation, just before the fairing halves were closed in preparation for flight. Once in space, the two fairing halves separate and fall back to Earth, where they will be recovered by our recovery vessel to be refurbished and reused on future flights. One half of the fairing is flight-proven, with one side flying for its 7th time and the other is going for its 1st. And then right below the fairing is Falcon 9's second stage, which houses a single Merlin vacuum engine, or MVAC engine. Below the second stage is the black carbon fiber inner stage, and inside of that is where the MVAC engine is located. The inner stage connects the two stages and houses the center pusher that allows the first and second stage to separate during flight. And below that we have the first stage, or booster, whose skin is pale white and ice cold now that it's loaded with about 1 million pounds of liquid oxygen and RP1. The first stage supporting today's mission will be making its 5th flight today. And the first stage makes up the bottom 2/3 of the vehicle and has 9 Merlin M1D engines at the bottom, which generate more than 1.7 million pounds of thrust.
Falcon 9 tanks are pressing for strongback retract.
About 2.5 minutes into flight, the first stage will separate and make its way back to Earth. And today the booster is headed back towards Space Launch Complex 4 West at Vandenberg Space Force Base. So coming up next, the truss structure next to the vehicle, known as the strongback or the transporter erector, will start to retract. In preparation for retraction, those clamps around the second stage.
Strongback retract has started.
The clamps around the second stage will have opened, and then the strongback will begin to recline away from the vehicle. And you can see that those arms are starting to come open now. It's going to take about 15 seconds for them to fully open, but once they're out of the way, then the strongback will recline back away from the vehicle and give it room for liftoff. Now those clamp arms are fully open, and the rocket is fully free at the top. The launch tower strongback is now moving away from Falcon 9, giving it room for liftoff.
Stage 1 LOX load is complete.
LOX loading has completed for the first stage, finalizing propellant loading for the booster. Right now, both stages are nearly fully loaded with about 1 million pounds of propellant. That includes RP1, which is a highly refined kerosene, and LOX, or liquid oxygen. Propellant is loaded late in the countdown, and that's intentional. Colder propellants are denser, and denser propellants means more performance out of the same tanks. So the colder it is, the more mass you can move. Before any of that propellant flows, though, the plumbing and engines are chilled down. That prevents thermal shock and boil off when the ultra-cold liquid starts moving. You may hear that referred to as engine chill.
Stage 2 LOX load is complete.
Liquid oxygen for the second stage is now fully loaded, completing prop load for the upper stage.
Ground gas closeouts.
We heard the call out that gas closeout has started, and that refers to venting and closing out gaseous systems, such as topping off tanks and sealing vents to maintain pressure. We're standing by now for the confirmation that Falcon 9 is in startup at the T-1 minute mark.
Falcon 9 is in startup.
At this point, the autonomous flight computers have taken over the launch countdown, and stages 1 and 2 are pressurizing for launch.
T-minus 3 seconds.
LDs go for launch.
T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. And liftoff of Falcon 9. Go SpaceX, go Twilight.
Vehicles pitching downrange.
M1D, chamber pressure nominal.
At T plus 30 seconds into flight, Falcon 9 has successfully lifted off from Space Launch Complex 4 East at Vandenberg Space Force Base in California. We're currently throttling down to prepare for max Q, the point of maximum aerodynamic stresses on the vehicle.
Power and telemetry nominal.
Max Q is reached when the air density of the atmosphere decreases faster
Falcon 9 is supersonic.
than the increasing speed of the rocket.
Max Q.
And there's the call out for max Q. Merlin engines are now back at full power, and we're out of the throttle bucket. Now we have several events coming up in quick succession, starting with MECO, stage separation, second engine start, or SES1, and the boost back burn.
MVAC chill.
Main engine cutoff, or MECO, is where all 9 Merlin 1D engines shut down to slow the vehicle down in preparation for stage separation, where the first stage separates from the second stage. Then the MVAC engine on the second stage will light, which is called out as second engine start 1, or SES1. This engine burn, lasting several minutes, will propel the second stage and our payloads to orbit.
Trajectory.
Then we'll see the start of the boost back burn on the Falcon 9 first stage, followed by fairing separation, where where the fairing will jettison from the second stage as it's no longer needed to protect the payloads once we're in space.
Main engine cutoff.
Stage separation confirmed.
MVAC ignition.
Stage 1 boost back startup.
And there you heard and saw those events that happened back to back, including main engine cutoff, stage separation, stage 1 flip, second engine start 1, and the boost back burn. Coming up next will be fairing separation in just a few seconds from now.
Fairing separation confirmed.
And there we just heard confirmation of fairing separation, along with a great view of those two halves separating from the vehicle on your screen. As a reminder, those fairings will make their way back to Earth for recovery. The next major milestone coming up is entry burn on our Falcon 9 first stage, which is scheduled to occur around the T+6 minute mark. The entry burn is used to slow the first stage as it heads towards Space Launch Complex 4 West.
Stage 1 boost back shutdown.
We're currently in our first MVAC burn, and this burn should last for another few minutes. The next milestone will be the first stage entry burn. Today, Falcon 9 is performing 2 burns in order to land. The first burn slows the vehicle down before hitting the denser parts of Earth's atmosphere. Without this burn, we'd only be using the atmospheric drag to slow down Falcon 9, which would add extra stress to the vehicle. Following entry burn, the booster will initiate the landing burn, which should slow the vehicle down even more for a successful landing. When Falcon 9 fires up the center M1D engine for re-entry, the vehicle will be flying through Merlin's exhaust gases, which is also known as the rocket's plume, which deposits a layer of soot on the vehicle surface. You'll see these marks across the flight-proven Falcon 9 first stage fleet. That soot comes from the carbon-based fuel that Falcon 9 uses, and with each flight, the soot builds up a little more on the outside of the
Trajectories
vehicle.
are nominal.
We are still over a minute away from the beginning of the entry burn. You can check out the telemetry on the bottom of your screen, and you can see that the second stage is still picking up speed and heading towards its destined orbit. We are moments away from the beginning of the entry burn. You should see the graphics light up as the engines do on the bottom of your screen.
Stage 1 entry burn startup.
There's the call out for the entry burn startup on the Falcon 9 first stage.
Stage 1 entry burn shutdown.
Again, that was slowing down the vehicle in preparation for its final burn and landing. As mentioned earlier, we will be attempting to recover this booster. The booster is targeting a landing at Space Launch Complex 4
Stage 1
West.
FTS has safed.
As this burn happens, you'll notice a decrease in both speed and altitude. We should expect
Stage 1 transonic.
the landing burn within the next 10 seconds.
Stage 1 landing burn.
And there you heard that call out for landing burn start on the Falcon 9 first stage. Again, this is the final burn that this booster will execute before touching down.
Landing lead deploy. Stage 1 landing confirmed.
As you
Stage
saw
2 has entered terminal guidance.
and probably heard, we had a successful first stage landing. Coming up next, we are expecting the shutdown of the second stage MVAC engine. This is known as Second Engine Cutoff 1 or
Stage
SECO 1.
2 FTS has safed.
MVAC shutdown.
There was a successful cutoff of our second stage engine, and now we're waiting for confirmation of good orbit.
Nominal orbit insertion.
There was the call out for good orbit. The second burn of our MVAC engine on board the second stage, or SES-2, will be around the T plus 52 minute mark, and payload deployment is expected to begin at about T plus 59 minutes. We'll be back at about T plus 50 minutes to bring you live coverage of SES-2. Until then, enjoy our space tracks, and we'll see you soon. Welcome back to our live coverage of the Twilight dedicated rideshare mission. We've had a great launch and an overall mission so far. We had an on-time liftoff at 5:44 a.m. Pacific time, and we recovered the first stage for its 5th launch and landing. And then we had a successful first burn of the MVAC engine on our second stage. Following that, stage 2 entered a roughly 44-minute coast phase. We're expecting the second ignition of our Merlin vacuum engine here shortly, followed by the first round of payload deployments.
Nominal orbit insertion 2.
There was confirmation of a successful second burn of the MVAC engine on the second stage and confirmation of good orbit. So with that burn complete, we are on track to begin payload deployment in just a few minutes. We'll be back at T plus 56 minutes to prepare for the first batch of payload deployments. Welcome back to our live coverage of the Twilight dedicated rideshare mission. We are just minutes away from the beginning of the first round of payload deployments on today's mission. Coming up, we have the first of Connecta IoT's satellites. All 4 are manifested by ExoLaunch. Connecta IoT 14 is optimized for IoT devices in remote or hard-to-reach areas where terrestrial networks are unavailable or unreliable. And Connecta IoT 13 is part of a constellation designed specifically for direct-to-satellite IoT connectivity. Hydra 2, part of IceTech's Hydra platform and upcoming constellation, features the company's next-generation commercial multispectral thermal telescope. Manifested by ExoLaunch, it delivers advanced thermal Earth observation data for security, infrastructure resilience, and environmental monitoring. Spire Global is launching 9 satellites today, also manifested by ExoLaunch, including its next-generation hyperspectral microwave sounder, or HYMS demonstrator, a first-of-its-kind hyperspectral microwave sounder in a compact, space-ready form factor. HYMS is built to capture detailed profiles of temperature, humidity, and precipitation, helping forecasters understand how weather systems form and evolve. Spire is launching 8 satellites for customer Myriota, further expanding their IoT satellite constellation. And we're about a minute away from the expected beginning of our payload deployments.
Connecta IoT 14 separation confirmed. Hydra 2 separation confirmed. Lemur 2 Kutar separation confirmed. Connecta IoT 13 separation confirmed. Hawk 13B separation confirmed.
The Cluster 13 payload from Hawkeye 360 includes advanced RF detection sensors, enhanced onboard processing, and upgraded waveform collection capabilities designed to capture a broader range of signals with greater clarity. The satellites, manifested by ExoLaunch, also feature improved data handling that streamlines the delivery of RF insights to customers. Together, these enhancements strengthen multi-domain mission support and increase overall collection capacity.
Tomorrow S11 separation confirmed. Tomorrow S10 separation confirmed.
Tomorrow S10 and S11 are the 10th and 11th microwave sounder satellites deployed as part of a constellation for weather observation across the globe. The instruments are used to significantly enhance weather forecasts with sub-hourly revisit rates of observation globally.
Connect to IoT 16, separation confirmed.
Connecta IoT 16 is the newest member of the Connecta IoT constellation, owned and operated by Plan S.
Connect to IoT 15, separation confirmed.
Connecta IoT 15 is optimized long-range wide-area network-based connectivity, enabling small data packets with very long device battery life.
Hawk 13A, separation confirmed. Flamingo 1, separation confirmed.
Vioma's Flamingo 1 is Europe's first commercial mission for in-orbit space surveillance. Manifested by ExoLaunch, this space surveillance mission will enable Vioma and Europe to monitor the space environment for detecting debris and international threats. Vioma's first satellite of its constellation, Flamingo 1, will contribute to European security efforts and the safe use of our orbits.
Hawk 13C, separation confirmed. Carbsar IOD, separation confirmed.
Surrey Satellite Technology and Oxford Space Systems have collaborated to build and launch an OSS-3M wrapped rib antenna mounted to an SSTL CarbSAR satellite. This in-orbit demonstration mission advances both companies' abilities, with Oxford Space Systems gaining space heritage and Surrey building its ability to integrate capability from new suppliers. The work has been jointly funded by Oxford Space Systems, Surrey Satellite Technology, Airbus Defence and Space, the UK's National Security Strategic Investment Fund, and is proving a groundbreaking synthetic aperture radar concept. And that concludes the first wave of deployments. We're heading back into a coast now, and we'll see you back here at about T+1 hour and 37 minutes for SES-3. Welcome back to our live coverage of the Twilight dedicated rideshare mission. In case you're just joining us, we had an on-time liftoff at 5:44 a.m. Pacific time, and we recovered the first stage for its 5th launch and landing. Then we had a successful first and second burn of the MVAC engine on our second stage. Following that, we had the first wave of payload deployments. We're expecting the third ignition of our Merlin vacuum, or MVAC engine here shortly, followed by the next coast phase. We should expect the start of the next burn within the next minute.
Nominal orbit insertion 3.
And there was a successful third burn of the MVAC engine on the second stage and confirmation of good orbit. We're heading back into the next coast phase now, so we'll see you back here in about 30 minutes at T plus 2 hours and 11 minutes for SES-4.
there and look at a rocket from Mars, and you just boggle the mind and mind and mind and mind. And the technology caught up to them.
Welcome back to our live coverage of the Twilight dedicated rideshare mission. We've had a great launch and overall mission so far. We've had 3 successful burns of the MVAC engine on our second stage so far, and we're expecting the 4th ignition of our Merlin vacuum, or MVAC engine, here shortly. We should expect the 4th ignition of the Merlin vacuum engine within a minute.
Nominal orbit insertion 4.
So there was the 4th burn of the MVAC engine on the second stage, and we had confirmation of good orbit. Coming up next is the 2nd round of payload deployments, starting at around the T+2 hour and 20-minute mark. In this deployment sequence, we'll be expecting first the Lemur 2 HCS BASA satellite. Spire Global is launching 9 satellites today, manifested by ExoLaunch. Next, the Black Cat, or Black Hole-Coated Aperture Telescope CubeSat, manifested by ExoLaunch, is an X-ray space telescope that is optimized for the detection of X-ray emission from rare and bright gamma-ray bursts from the early universe. Nearby short gamma-ray bursts that are likely to accompany gravitational waves, and X-ray flares from active galaxies with supermassive black holes. Black Cat is a NASA-funded mission that is led by Abe Falcone at Penn State University, where the payload was designed and built, and also has flight software contributions from researchers at Los Alamos National Labs. You can see incredible views of Antarctica beneath Stage 2. For Black Cat, the flight-proven spacecraft bus is provided by Kongsberg Nano Avionics. D-Cubed-1 Arrakis D1, manifested by Exolaunch, is a pioneering 3U CubeSat on a mission to build in space the way that we build on Earth, aiming to achieve humanity's first manufacturing of a structure in free space, a breakthrough known as in-space manufacturing, or ISM. During the mission, the satellite will create a 60-centimeter boom in the vacuum of space, demonstrating that complex structures can be formed far beyond our planet. This pathfinder opens the door to a future where large solar arrays, antennas, and space infrastructure are not launched from Earth, they're made in space. The Star Planet Activity Research CubeSat, or SPARCS, supported by Maverick Space Systems, is a telescope about the size and shape of a shoebox that will use thermal infrared cameras to study coronal mass ejections on small stars, aiming to understand how these eruptions impact exoplanet atmospheres. NASA's Jet Propulsion Laboratory in Southern California also participates in the mission. NASA's CubeSat launch initiative selected SPARCS in 2022 for a ride to orbit. The initiative is a low-cost pathway for conducting scientific investigations and technology demonstrations in space, enabling students, teachers, and faculty to gain hands-on experience with flight hardware design, development, and building. Capella is launching its Acadia 8 and Acadia 9 satellites, adding to its growing SAR constellation and strengthening its ability to deliver precise, reliable Earth intelligence in any weather, day or night. 45 days after launching its next-generation systems, Umbra 12 continues to operationalize the most advanced SAR fleet on the market through deeper integration and faster delivery. Built with the highest proportion of in-house, U.S.-made components to date, Umbra 12 delivers resilient, mission-ready performance across any environment, day or night, in all weather. From SAR data and complete satellite missions to critical space components, Umbra delivers what the mission demands. Pandora is NASA's latest exoplanet explorer, designed to peer into the atmospheres of previously discovered planets orbiting distant stars. Pandora is a small satellite that will study at least 20 known planets using transits, events where planets passing in front of their stars cause tiny dips in the star's brightness. These observations will lay the groundwork for future investigations of potentially habitable worlds. Kepler's payload consists of 10 300-kilogram satellites equipped with high-capacity SDA-compatible optical terminals and multi-GPU on-orbit compute modules with terabytes of storage that enable low-latency data transfer, secure routing, and edge processing directly in space. Kepler's network will provide real-time connectivity, advanced computing, and hosted payload capabilities, creating a cloud environment on orbit for critical commercial and government space missions. And we have ICE-I payloads that are manifested with Exolaunch.
Lemur 2 HCS Basis separation confirmed. Lemur 2 Callum KJ separation confirmed. Black Cat separation confirmed. Lemur 2 Katie separation confirmed. D-Cubed-1 Arrakis D1 separation confirmed. Lemur 2 Mario Souza separation confirmed. Spark separation confirmed. Lemur 2 Sonnenbloom separation confirmed. Lemur 2 Graham Isu separation confirmed. Lemur 2 Wobbler, separation confirmed. Lemur 2 Fikret Dengiz, separation confirmed. Acadia 8, separation confirmed. Umbra 12, separation confirmed.
Aether 8, separation confirmed. ISI 2, separation confirmed. Acadia 9, separation confirmed. Aether 12, separation confirmed. Aether 11, separation confirmed. Aether 5, separation confirmed. ISI 1, separation confirmed. Aether 9, separation confirmed. Aether 6, separation confirmed. Aether 4, separation confirmed. Pandora, separation confirmed. Aether 3, separation confirmed. Aether 7, separation confirmed. Aether 10, separation confirmed. All rideshare payload separations confirmed.
And that confirmation means that we are at the end of our live mission coverage. We would like to thank our rideshare customers for entrusting us with their spacecraft today, and we also want to say thank you to the Range and Federal Aviation Administration for their support, and to you, our viewers. And for more launch coverage, be sure to check out spacex.com/launches for the most up-to-date information, or follow us at SpaceX on X. Thanks again for joining.